What we're doing here is balancing something called redox reactions. When we balance redox reactions, hopefully it's already in the net ionic equation for you like we have here. This is our net ionic equation, and these can be difficult to balance because we also have not just atoms to worry about, but we also have electrons. That's what's happening in a redox reaction. So the key is to split it into what we call half reactions. And what that means is I want to look at the oxidation half, and I want to look at just the reduction half. So to do that, I'm going to assign some oxidation numbers to these things. And so we learned in a previous lesson how to assign these. And so when I look at this for the oxidation half, oxidation is losing electrons. So we would say that the Cl minus is going to form Cl2. That was losing an electron. And so then the reduction is going to be the manganese, MnO4 minus, is going to form Mn plus 2. So the first thing we want to do is balance our atoms. So I see 1 chlorine on the left and 2 chlorines on the right. So I'm going to put a coefficient there. The next, I'm going to balance the Mn's. There's 1 on the left, 1 on the right. But I notice there's 4 oxygens on the left. So I'm going to go ahead and add 4 oxygens to the right. And the way that I'm going to do that is I understand that all of these things are always going to be aqueous. I have waters available. So I'm going to go ahead and put 4 H2Os in on this side. And then when I do that, most of these redox reactions are done under acidic or basic conditions. And so here we can see that this was done under acidic conditions. So if I added 4 waters, I have 8 H's. So I'm going to need to add 8 H pluses to this side. Finally, we understand that redox reactions are exchanging electrons. So I need to balance the electrons as well. So on this side, on the oxidation half, I notice that I have 2 Cl minuses. So this side is basically a -2. And over here, this side is a 0. That doesn't balance. So I know that this is going to need 2 electrons on this side. And that way, my charges will balance out. Okay? So we can say that those are now equal. Over here, when I look at this one, I have 8 H pluses minus 1. Is a +7. Over here, I have a +2. So I'm going to add 5 electrons to this one. So basically, -5 plus 7 equals a +2. And so those things match. All right. So now we know that our charges are all equal. And so now we can look at these equations and decide, is this redox reaction making sense? So the oxidation half tells me that I am losing 2 electrons. So the chlorine is losing electrons. Where are those electrons going? Well, we know that the manganese is gaining. So the chlorine is passing its electrons over to the manganese. But the issue I have is 2 electrons are being lost, but 5 are being gained. So that doesn't work. We have to lose the same amount that we gain. So I'm going to take this and multiply this whole thing by 5. So now I'm losing 10 electrons. And this one, I could multiply the entire thing by 2 so that I'm gaining 10 electrons. Now I can go ahead and add all this back together. So 5 times 2 is 10 Cl minuses. I have the 5 electrons there, but times 2, so I have 10 electrons, so that 2 right there, and then 2 times the 8 gives me 16 H pluses, and 2 times the MnO4 gives me 2 MnO4 minus. And then on the reactant side, that's all complete now. I could look at the product side. So once again, 5 times the Cl, so I have 5 Cl2s plus 10 electrons plus 2 Mn plus 2s, and I'm running out of room here, plus 8 H2O. And then just like Hess's law, I could look at the left and I could look at the right, and anything that is equal in number will cancel. And the only thing I see here are the electrons. So there's 10 electrons over there and 10 electrons over there. And so this is my final balanced equation. It's all finished up and we're good to go. All right, I hope that helped you out. Let me know in class if you guys have any additional questions.